How's it going, everyone? Welcome. Julier Gonzalez here. So let's take a look now at the objects, particularly on how they behave, not only typings, but the JavaScript behaviors, and what TypeScript authors actually try to describe via certain typings that. So you have now types, and you also have is interface. And in order to describe the shape of these objects, well, you can go with types, and also you can extend the functionality of that using now a JavaScript. You can extend one of the behaviors of objects, which is how do you extend the functionality of an object. So for example, if you have now some piece of information and data, how you can now enhance that, right? So it's also have a lot of relationship with the, and I'm gonna make a quick segue into this video, which is the enhance sport, something like that. Exactly. It's for enhanced games like this, you know. So Las Vegas will host, I don't know when. Oh, in 2 days. And they already planned this. Anyway, they know that a lot of people, they oh my god. Oh, so why am I doing this? Why I exhaling in this way? Because they know that 25 May. Oh my God! Oh, yeah. 25 day is the Memorial's Day, you know. So what will be what would be a great way to remember all of those fallen loved ones, uncles, parents, so on and so forth, with now is this gain. So with now this new era of enhancements, especially in the sport. So that is my God, a good segue that I actually I'm taking here, because so the U.S. at the end of the day, especially things that are hosted in Las Vegas and all that kind of stuff, they don't do things because they just want to do that. They already test this, or they sometimes do this beta testings to see how that actually works and fit, and how they can is influence with the dollar, and then infiltrate, and perhaps is dominate from inside, or subordinate or compromise them, right? So I'm mentioning is this because when you want to enhance the features of something, so for example, in the case of athletes, if you are some let's say you are now a powerlifting, and then you want to enhance the capacity that you can live on, right? Roughly, I think most of athletes, or the strongest one, can lift like up to 400 500 lips, something like that. So in Hall thereof, power lifting greatest lifting in history, you know. Okay, the world record. Holy hell. All right, okay, holy fuck. All right, okay, in powerlifting, right? So yeah, that's also part of the Western cultures, and the ethos of Western culture is hey, we always want to break the limits, go above, go beyond that, do something that only gods can do, and there is nothing wrong or there is nothing good or bad about it. It's just the way it is. Okay, so it's this one. It's like 2,400 lips. Oh my god! Oh, 2,400 pounds. Jesus. Okay. So, um, so this is it, right? So I actually, uh, I want to go back here to this course on that, because at the end of the day, this is something that it doesn't live in the abstract. All right, that's the whole point of taking this segue. This is part of the nature of life. All right, so perhaps you as a software developer or somebody that's going to deal with data and processing that kind of data, right? So some of those data, some of those systems that you need to enhance or extend its functionality, right? So for example, pretty much like enhance Spore, right? So JavaScript, or the creator of JavaScript, Brendan H. Back then he created now this particular way, leveraging is all the software engineering learning for the past, at that moment in 1993, for the past 30 years. All right, so you don't want to miss that. So the way how you can enhance these objects here, let's gonna do this, right? So the way you can do this is by, hey, I want to define now some object. Let's say, actually, let's gonna go with this example here, which is the athletes, right? So let's say I'm gonna call this athlete, right? Athletes, athlete. I don't know how you. Oh my god. Athlete. All right. Athlete. Is this one? Oh, this is athlete. All right. So athlete. All right. So now these athletes. Right? Let's say it has a name. In this case, is my name, right? And it also has some age, right? Right now, and this one, okay. And it also have some features, right? So it's gonna call is features or disciplines, right? So the disciplines, and inside of this, I want to define some couple nested stuff here. So hey, do you have so you have MMA, right? I have MMA, and I can say, hey, yeah, this is true. So he knows MMA. All right. So what about is rings, or in this case, it's gonna call this MMA. All right. How do you swimming, right? It's a no, doesn't have that, right? And just to mention at least this skills or this discipline, right? So this is for the athletes, and if you want to now enhance these features, all right, you can now say is now this athlete, which is enhance athlete, right? Enhance and enhance, okay, athlete enhance, right? So instead of copy that information over and over and over, which is quite tedious, you might rely on some of the built-in objects or behaviors, APIs that JavaScript provide for us. So you have now the object dot assign, I mean the yeah, dot assign it is yeah, object dot assign. All right, and you say, well, the target object, which will be this new object here, and the source, which can be only one or a collection of them, in this case, come from this athlete. All right, athlete, right? But I do want to additionally, or to enhance the capabilities of these athletes, right? So in this case, I can say is, well, if you have some property called this disciplines, right? And if you have something called now swimming, I want to set now this to true, and also is for, let's say, is firefighter, right? Firefighter, you say now this is true. Okay, so what I'm doing here is now enhancing that and say unexpected token. Yeah, you're right. Yes, there was a missing one, right? And now athlete enhance athlete. Why you don't allow me to take a look at that? Doesn't matter. Console log athlete enhance. All right. So now, yes, you have, of course, all of the keys and values from these objects, plus the new one, which is discipline. Swimming is interesting. I don't know why they didn't actually update that. Okay, because I think it's something like this. So you provide is the target, and also is the source, which is what you're going to enhance from this object. So I can call this athlete 1, right? And now I should be able to see that, right? So is this one, right? So as you can see, this is a way of how can I, oh my god, and I forgot. And I forgot is, that's interesting. And I forgot is the MMA here, right? Unfortunately, it forgot that. So again, this is internal behaviors of JavaScript, right? So because yeah, it is interesting. It forgot about that. Yeah, and it makes sense because it forgot is what it has. So it overrides. So it step over things. So what's the thing here is that this particular behavior, especially on nested objects, what happened is, well, you have to recreate again that particular object, and this kind of recreations to create a new copy, enhance, right, is something that can become quite tedious. So, well, the language evolved to say anytime that you need to create something like that, right, instead of using as the object.assign, which is perhaps is using behind the scenes. So let's go into now is do something more simple. So is say the spread operator. So wrap this into a new object, which is the way of how you say, let's going to create JavaScript and reserve a spacing memory for this data structure, the objects here, there in memory. And I'm using is this spread operator, which is say, hey, I'm going to iterate over this identifier that you give me, as long as that has an iterable interface, as long as I can iterate through that element. How do you check that? Because it has some of these well-known symbols that say, hey, is iterable? If it, I think it's iterable or iterator, but it is. Okay, so now let me actually is walk through each one of those elements. So by calling this function, or because this identifiers has already implemented this protocol of how can I walk through these collections of values, in our case in an object, which are key and value, right? If you are in another data structure like arrays, it gives you now the elements, right? Or any other application or any other object that implements the iterator protocol, aka, hey, these identifiers, for example, in our case, athletes, all right, what's representing is something that you can iterate over, right? So that's the whole point of this, right? So good, makes sense, right? So const athlete and hence 2, where you say JavaScript, please reserve a spacing memory for this thing that I'm about to create, call these objects. And for each one of those elements, key and value, I want you to now is append them to this new object, plus, by adding is a comma here, plus this thing here, right? Which is discipline, diggy, and there you go, right? So if I now inspect after I go to this and say athlete, and hence 2, right? So now, so this athletes, so now can swim and firefight. It's a firefighter, right? Firefighting. So why am I mentioning this? Well, because this is one of the behaviors that Typescript wants to replicate here, and because this behavior, which happens at runtime, it needs to replicate that at build time, and doing so is actually something that allows you avoid you a lot of bugs in the long run. Well, it makes sense to actually is creating this kind of or to use some of the ways to describe objects and its behaviors. So interface is one of those labels, right? So in this previous or in this section, right, where Matt Pocock, which is the software engineer that previously worked at Vercel, and now he's the creator of this particular course, right? So in this model, we were actually describing is, well, how you can enhance that behaviors with types and interface. So with types, you do that is the ampersand to do so, to describe the behaviors, and with interface you use now the extends to do so, right? And well, some of the gotchas, for example, when you want to define is an object with the same name several times. Using types is gonna throw you now an error pretty quickly, immediately. But if you use now interface, it's going to mash down all of these key values in these objects, and then generate is now this new one. So it's going to overload, if you have now function signature as I mentioned, it's going to overload those function signatures, and if some of those key when they merging that doesn't or they have the same name, you're gonna throw you now an error, but not at the identifier layer. So in other words, when you define is the interface here. So why am I mentioning is this? Because in TypeScript, when you use now interface and types, there is no good or wrong solutions. It's just that each one of them has its own trade-off. So for example, if you're using types, you can leverage this type system in your favor, which is, hey, I can now dynamically define its keys in these objects. I can is restrict how much key this object might have, all right? And I can also describe is the optional values that this object can have as well. And some of these typing things, but with interface, you don't have this, but you have now the catching ability that the compiler, that anytime that it look an expression like this, is going to store that in memory, so it doesn't have to recompute that. Especially when you now use the extend, right? Which is something that with TypeScript or with types, when you're using the ampersand, yes, anytime that it see that operator, it have to recompute that. So this is the difference between now the interface and the type, which I find that out very, very interesting and revealing, right? Because with that, then I can look at what are the common operations that we have to do when working with objects, right? So for example, like, hey, I want to make some of these key optionals, using partial to set all of the key optionals, or require, or you want to only, or you want to discard a couple of these elements. So you use now the omit. For example, you want to omit some of those keys. And how now, for example, or you want to now cherry picking keys from these objects. So cherry picking here now is something that allows you to provide autocomplete, whereas omit doesn't. And you can also look at why was the decision that they made this, and I do find that out very interesting, and I promote you. So hey, please go out and take a look at this, right? And see how actually and why the implementation of omit is loosely, right? So it doesn't care about it. So this is one of the reasons why it doesn't provide you autocompletion, unlike pick. So that's very, very interesting, right? Because making type property required, yada yada, because now we enter into the realm of another behavior, and that is the mutability here. Which let's take a look at this and let's get into this.
In this exercise, we have a const here called button attributes, and this is an object that basically just has a single property. It's being typed as a button attributes type, and that type has a type property, which is either button or submit or reset. Those are the three possibilities. And you might have seen this. This is kind of like a kind of dummy version of what happens in the DOM. If you want to edit the type of a button element in the DOM, it can either be of type button, submit, or reset. Now we have a let here, which is saying let type equals button, and then we're assigning that into the button attributes object, but we're getting an error in there. Your job is to work out why that error is occurring, what's happening to cause that error, and how we might fix it. And you're only allowed to change this line of code with let type equals button, but you can change the runtime thing of the code, like behavior of the code if you like, and you can change, you can give it a type if you like. So good luck.
So let's take a look at this exercise to see if this now works. Oh, really? Oh, okay. Yeah, but so now this doesn't work. It also doesn't allow me to, it doesn't provide the auto completion features or highlight the errors. So it's like death, bro. it dies. Let me do something real quick here. Yeah, it's like, so it died. It died. So okay, this is how you gonna work. Problem. Mm-hmm. Mm. 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 That's the only one. I don't believe it. Okay. Cool. Well, let me open up here. Mm. Mm. Oh my God, what is it? What is the name of this? This is okay? Yeah, okay. Math courses, Pro Essential Workshop, and then you got all of this. But I think the Git is here. So if I open up here. So yeah, okay, all right, okay, cool, cool. Be my guest. Date it, take it, and okay. All right, cool, 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 cool. Yeah, awesome. Yeah, but I think there is a lot of that is missing here. 097. Let me see if I can find that. 097. Oh, I find it. All right. Okay, cool. Cool. Okay. So now this actually works here. Let me flip the. Yeah, let me flip here real quick. Yeah, I want to capture the video from VS Code, so I'm doing that. So Visual Studio Code, we're in the French stuff. Where is VS Code? Why you are not? Okay, so VS Code. Oh, they call code. All right. And there you are, right? Okay, cool. So I know that right now you're not able to see me. I need to fix this lights, but in any case, so this is the issue here, right? So now it's saying, hey, the type string is not assignable to a type button. Submit or reset. All right. So it's the expected type come from property type, which is declared here on type button attributes. However, I am here saying, hey, I'm gonna create now an object where it is possible values are now this button, submit, and reset. Right? So this is an object type. It is used to represent object, union type, and literal type. Okay, that's quite interesting to describe what is this. This is a type, the literal types, and the union. But here's the thing. It's say, hey, the expected type comes from property type, which is declared here on type button attributes. If I take a look at this, and I view the problem, you say the type string is not assignable to type button, submit, and reset. The expected type comes from property type, which is declared here on a type button attributes. So somehow you are not able to assign these values here, right? Despite that I'm telling you to do so. And it's here to say, hey, this is type button, submit, and reset, but the type string is not assignable to type button, submit, or reset. Because here I am creating is this object, all right, and this type, which is an identifier here, which values is now bottom. Somehow Typescript has some problems of figuring out what is the value of this reference, right? It say, hey, this is a type string. Makes sense. So if I say, hey, well, the possible value that it can be is, well, you say bottom attributes, right? Attributes, but not the whole object, right? In fact, I want is just the type, right? So how can I somehow try to get access to the type attributes? Okay, so if I say something like this and say pick here, right, and pick, it say, hey, I want to now from here try to from this object I want to get is the type. And it's interesting because now Typescript actually autocomplete this for me. If I say type here, right, and this is now a button, all right, so I am very explicit about this. So the types here is a string is not assignable to type pick. So what is the potential value that this can be, right? So shouldn't be access to, should I not be able to say this? So somehow we say no, from T, which is the object, all right, pick a set of property whose keys are in the union of key. And in this case, I'm saying is, well, I do want to get is the type, right? So is this how it works, right? So I do want to get is the type from here, right? This annotation tells the variable what type it should be, right? So is this. So in other words, somehow the string is not assignable to the type pick attribute type, right? Despite that I'm trying to make that happen. I was expecting a type matching pick button string type, but instead you pass string. So Typescript here is saying is like, hey, well, you need to somehow so I'm passing is you now, okay, so I'm passing is you now a value. So whether if I say I assert this type, right, as like this, so whether if I say something like this, No. This is one of these possible values. It's a conversion to type string to pick may be mistake because neither type sufficiently overlap with the other. If this was intentional, convert the expression to unknown first. So I need to do something like unknown and then something like this, right? So now this type is this. So if I now pass the type here, right? And it say, hey, the expected type come from property type, which is declared here on button attributes. And it say, I was expecting the type match type pick button attribute type is not assignable to type button, submit, or reset. So in other words, somehow it's not able to pick the proper type for this case, right? So okay. No problem. So what happened is that I need to be explicit about when I using a value as a reference, as as a value as a reference here, because I need to say something like this. I need to say something like, hey, this type must be is whatever value you have there, right? So somehow I need to find is this, to define that, right? To say, hey, this is now the type, all right? This is not the type, and this is the value here. But again, this value must be one of this. So, so whether I say, hey, whether I define is a new type, all right, where I say is bottom types, all right, and here I say, well, this will be now a union of all of this, right? And I want to copy and paste this, not at all. Okay, and then here at this is on the type definition, all right, and I say, hey, all the possible values that this can be are they, right? But if I define this later on, it still have the same issues. You say the type string is not assignable to type button types. So the problem here is that somehow this type, and even is telling you here, so this type, what if I say, if I be more explicit and say, hey, all the possible values that this can be are just a type, button types, right? And if I hover here, this annotation tells the variable what type it should be, all right? So I am very explicit about what are the possible values, primitive values that I'm using here, all right? And when I try to use that, right, down below, so if I hover this, now this actually work as expected, right? So there is no error here, right? All of this thing here are just like that. You know, I don't have any errors here. So not only that I fix this error, I can also let me actually take a look at the package JSON of the package JSON at yeah, because I want to run this. How can I run this? CLI run script exercise. npm run exercise. If I say npm run e, so this is the no command found. Let me install here the dependency here, but let me use now is pmp install. This is way much more performance and save memory. Yes, okay. So if I say now npm run, holy moly, all of this. But in my case is say hey s or exercise 0097, right? 0097 npm run that, right? It's checking the type, and it's saying me this type string is not assignable to button, submit or reset. Let me save that, and now it works. The only thing that I changed, right, was this. Yeah, if I save this, right, yeah, there is no button type, but the only thing that I changed was that. So in objects, when you want to specify the arrays of possible values here, especially on the reference here, you have to be you have to be explicit about what are the possible values when using a primitive like strings. All right. Not for the type, but for the JavaScript code. So if I put it now here, right? So that actually works, but it's interesting. Again, this is the annotation for all the possible values that a variable can be. All right. So somehow it doesn't allow me to, and I have to be explicit about this. I have to tell the compiler, hey, this is the possible value that this type can be, the all possible states or values that it can be. Okay, that makes a ton of sense. That makes a ton of sense. If I look at the solution here.
Okay, the question at the heart of this exercise is why is this erroring in the first place? We're assigning button to the type, and so when we pass it into our button attributes, well, it's going to be the same. So why doesn't TypeScript, why is it erroring here? So we can look at this type here, and we can see that it says type string is not assignable to type button, submit, or reset. If we hover over type, you can see that it's being inferred as type string. Why on earth would that be right? Because what we're doing here is we're saying this is a button. Why doesn't it just infer as type button, the literal button?
Well, because, again, TypeScript infer is types, not values. That's the whole point of this.
Well, this is because let can be mutated. We can, further down the line or elsewhere in our code, say type equals something else.
Or it can be mutated as well. But again, what I mentioned earlier was that the type string TypeScript is inferring. TypeScript is inferring is types, not values at this moment. So it's trying to do it as best it can, but because the behavior of let and const and var is mutable, is assigning to this, well, primitive, right?
And it won't complain. We can, of course, do something funky here. We can give type an explicit type and say it can either be a button or submit or reset, and then everything's fine, right? It doesn't matter, actually, that the type can be mutated. It's more that when you use let by default, TypeScript infers it as the widest possible version of that type because it can be changed and mutated. But what?
Inference, and here is this. So TypeScript here, when you're trying to now describe all the possible values that a let can be, it automatically infers that to the widest, which is the primitive values here.
What if we use const instead? Const now says const type equals button, and it gets inferred as that specific type. That's because if we try to change it later, type equals something strange, it would say you cannot assign to type because it is a constant, and this would throw a runtime error too. So TypeScript is actually copying the behavior of JavaScript in this case, and it's saying, okay, if you declare this as a const, I understand that this is supposed to be of type, the literal type that you specify. And this means too that if you specify something else in there, it specifies the literal in there too. So type could be true, and then it would do that too. This is a really interesting behavior, and it touches on the idea that TypeScript pays attention to mutability a lot when we're kind of talking about like types and inference, and we're going to see that a lot, that TypeScript copies the behavior of JavaScript when it infers literals in your code.
That's a very interesting behavior. And let's take a look at the TypeScript manual here. So the authors of this tool, they put a lot of attention to that. Holy moly. This is the basic everyday type narrowing and more functions, type manipulation, classes, reference, utility, declaration merging, decorators, namespace, symbols, namespace, type inference, like this. Exactly. So TypeScript by default is just to inherit, straight to guess what is the possible type that a statement is. All right. So when you're using now let, which the behavior of let at the end of the day is just to, hey, you can now you cannot redeclare this identifier, for example in this case x. I mean, exactly, you can have a declaration, you can have a bucket with the same name. Okay, so I use the name bucket because that's what we are doing when we assign something. All right, so we're filling it with something that it can be any of the primitive values. Okay, I'm filling it with that, right? And when I use now let, what I'm saying is that, hey, I can just fill this bucket with something else, with a different primitive or object's value, right? But what I can do is to redefine this identifier again, right? So it means that let, because it can mutate that state for a number or for then on from an array, and then so for something else, and so on and so forth. So that's what TypeScript is saying, is like, hey, when you're using let, I'm going to just to infer is the widest possible type. Makes sense. Holy moly. Okay, the notion of mutability. However, if you're going to use const, now I'm going to infer it is value. Okay. So number here, and the same for this is here. Again, it's best common type, right? And the same for here. So the value of this can be either is a rhino or an elephant or a snake, right? And the same for this, it can be now a class of animals. It's a collection of these animals, right? And then the contextual typings here. Type inference also work in other direction in some cases. This is known as contextual typings, like this. When you use now, okay, all right, that's interesting. So now it can infer what is the type in the shape of this parameter. Contextual type. Here's the TypeScript type checker. Use the type of the window dot on mouse down. function to infer the type of a function expression. On the right hand side of the assignment, when it did so, it was able to infer the type of the mouse event parameter, which thus contains a button property, but not a kangaroo property. Yep. This worked because window already have a mouse done declaring it is type. So Typescript already have that defined for this, you know, when you look at the global events handler here. So Typescript is smart enough to infer the type in other contexts as well, right? So that's a very interesting thing. All right, very interesting thing. So this is const handler tiki. That's right. We can also explicitly give type information to the function's arguments to override any contextual type. You got this on scroll, beep. There you got it. So it's describing is the type behaviors on let inference, right? If you take a look at the let, right? So if you now change to a const, okay, so now the value is actually that. So Typescript pays a lot of attention to that, my friend. Okay. Got it. Yep. Okay. So yeah.
When it infers literals in your code.
You complete that?
In this exercise, we have a modify button function which takes in some attributes which are button attributes. Similar to the previous exercise, this is just an object type with a type property saying button or submit or reset. We're then declaring a button attributes object with a type of button, and then we're passing it into our modify button function. But we're getting an error in here, very similar error to the one that we had before. We also have a similar setup down the bottom here, which is a modify buttons function, which takes in an array of button attributes. And then we have inside here buttons to change, which is an array of type button and type submit. We're passing that into a modify buttons function, and we're getting a very similar error. Your job is to work out why that would be happening and also how to fix it. Good luck.
Okay. I don't know why this actually doesn't work here. But in any case, this is now the 0998, which is the problem here. All right. If I stop this, and then I get this, right? So I have this error, is the argument of type string is not assignable to a parameter of type button properties of this. So it says that when you are passing now these button attributes, all right, somehow Typescript is inferring that as a global type, right? Especially when you are passing that here at type and const. So whether if we have to say, hey, be explicit about this, so button attribute is that, so you don't have that, which is quite interesting, because again, button attribute is not being inferring here. Okay, again, const inference works at the primitive values. All right. Okay. So const works at primitive values. But what about with object? Is like, you know, it's like, you know, I can. That's not how I was designed for. So you either be explicit about that, All right, say, hey, button attribute here. You're either being explicit about that, all right, and that now makes the error goes away. And then you have now this when you say, I'm gonna pass you in a collections of button attributes, all right. And the button to change, which is this, and again is this or that. So if I replicate the trick that I did early, if I try to replicate the trick that I did early, it say now the error is here. Say, hey, type properties is okay because it has to be a collection of this, right? But again, I have to be explicit about that. So again, Const replicates behaviors, or Const inference the types, the value, the literal types, but at primitive level. But when it comes to objects, you have to be explicit about that. So if I run now this exercise, right? If I say the 98, right? It actually worked as expected. Again, this is telling you now is how Typescript pays a lot of attention to mutability with const and let for primitive and objects. Okay.
Okay, let's figure this out. Button attributes then, why is this not assignable to the other one? Well, type string is not assignable to type button, submit, or reset. We've got a very similar problem. Even though we've declared our object with const, JavaScript actually lets you modify object properties in here. So we can't modify the actual thing itself, so we can't say button attributes is something different because you can't reassign to it, it's a constant. But object properties are fair game. Thanks JavaScript, but that is JavaScript's behavior, so
Yeah.
TypeScript is copying it.
Exactly.
You can kind of make this a little bit easier and make it work. The first way you can do it is actually just inline this. So you can just say, okay, modify button, passing in the type of button. TypeScript understands that in this setup, really, you can't like modify this object literal before it gets passed in there. It's literally in the parentheses. And so it will let you do it. That's perfectly fine. But the other way you might need to be able to do it is just by adding a type here. So with a little extra type hint, you tell TypeScript, okay, this is button attributes. It does exactly the same thing. It checks if it's button, reset, or submit, and you're good to go. So this is, I think, the sort of best way to get around this, either inlining it or just giving it the type straight up. The same thing is true with arrays. So with arrays, just behave like objects, we're now getting an array of type string here, or objects of type string. And it means that we can go into here and we can say button attributes 0 dot, or it might need to be this, dot type, buttons to change, that's it. Buttons to change, first one, grab the type and set it to something different, right? And we're getting an error here because it's, I think it's an optional chain. There's lots of fun stuff going on here, but basically we can do this, and because we can do this, TypeScript is scared of it, and so it won't infer properly. So the best way to get around this is to say button attributes and give it basically an array property on the end. So this means now that, and again, like it would pick it up really nicely if we just inlined it there. And so often what I find myself doing is not really declaring like that many variables outside of functions if all I'm doing is passing them directly in. It doesn't make a huge amount of sense to do that when you can just pass them in literally. So this is something that you might want to change about the way that you write your TypeScript. There are a couple of extra annotations that we'll see in this chapter that can help us out further down the line, but I want to give you a proper sense of how object properties infer so that you can kind of change the way maybe you declare your variables, and mostly you're going to want to inline them. Let's say that we have an update user function which takes in a user of type user. Now this type user has three properties, ID, name, and age. And inside the update user function, we want to be able to modify the name and the age, but we don't want to be able to modify the ID. The ID should always stay static. Your job is to work out how to change this type definition of user to give ID a read-only attribute. Good luck.
Read-only attributes or read-only properties. Again, let me take a look at the another example. That is going to 099. This one, that's right. Read-only attributes here. And it said Typescript should not be able to modify read-only variables, right? So if I say, hey, this is a read-only variable, well, I can actually now explicitly add this read-only keyword, right? I think it is. This is how can I do this? Perhaps it might be here, right? Say read-only. No, I think it's something that you can pass here. Move to a file. Why would I want to move to a file? No. But it's that particularly property. Again, we're still in the realm of objects. Okay. Still on the realm of objects here. The object types here. We're referring here, which is type and interface property modifiers. All right, which can be optional, read only, and also index signatures. All right, except property checks, right? To say, hey, you're passing that, right? Access property check. And getting around this check is actually really simple. You just override this or type assertion that. Extending type, whether it's using is the extend or the ampersand or known as the intersection types, right? From other type by extending them. Exactly. Interface extension versus intersection. And generic object types. And generic object types. Alright. Which I think this is where we are talking about here. The generic object type. And the same for this, the array type. The read-only array type. This is a utility. And the tuple here. So what are the possible values that this can be? And the read-only tuples here. That's interesting. Very, 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 very interesting here.
Okay, the solution here is pretty simple. TypeScript gives us a first-class way to do that. We can just add read-only before the ID property, just there. And now the ID property is read-only, and the rest of them are still mutable. So by default, object properties are mutable in TypeScript, and this is because by default object properties are mutable in JavaScript too. Adding read-only here doesn't do anything at runtime, right? It's just literally a type annotation, but it just gives you a bit more information and says, okay, if you try to mutate this, you can't do it because it's a read-only property. And I think a lot more people should be using read-only in their type definitions, because how often really are you mutating objects directly? Usually in the kind of front end or very immutable world that we live in, immutability is a key concept in front end applications and back end applications. Really, you want a lot of your properties to be read-only. So I think you should probably be using this a fair amount. But anyway, it's a very, very useful little type annotation that can really save you from quite a lot of bugs. We have a handle search params function, which takes in a search object of potential search params. We have, I've seen a bunch of these before. We have queue, which might be like a query, a page, page size, sort, and order. And all of these they're first of all optional, but we also want them to be read-only, because it does not make sense for you to be able to mutate these since they come from the URL. They're going to be a source of truth up there. So we should really have like a bunch of different errors down here telling us we should not be able to modify read-only, right? So all of these should not be able to be mutated. Now, of course, we could go up and sort of add read-only onto all of these. That's nice. But there is a type helper that can help us out, which can apply itself to search params and make sure that all of the properties are read-only. Good luck in trying to find it.
Okay, so there is a utility, the read-only tuple. Read-only tuples here as const. The generic object like this. So in this case, so let me now go back to the go here and say this. I think this is 100. Yep, of the problem. So come with me here, right? And here you can say is let's make all of this as const. I think you can add that to this expected here. That's why interesting. You can say, hey, as const, right? So if you mention that as the type, right? Search parameter as count. Let me actually go and see the 100 exercise. All right. It says, hey, you can add that here. So you can do something like this. It's expecting now a comma after that. So that's quite interesting. So how can I now make all of these properties to be read-only? Read-only tuple, read-only array. And read-only property. Using mapping modifier, you can remove read-only attributes. Okay, mapping modifiers, you can remove them. That's very interesting. That's interesting. I think that's something new as well. Key mapping via S. Okay. The important to manage expectation of what read-only implies is a signal during development time for Typescript, not an actual thing in JavaScript. Using modifier, you can remove read-only attributes. So, but it is possible to make all of those properties read-only, right? And I just want to make myself familiar with the docs. Property modifiers. Okay, property modifiers. Optional, read-only, index signatures, except property check, extending type, intersection extension versus interface extension versus intersection generic object types, the array types here makes a lot of sense. The read-only array type, right? Oh, the read-only array type. That's interesting. The array type, the read-only array type, the tuple, and the read-only tuple here. Or you can do something like, okay, so whether is you say, hey, make this read only, all right, it say, hey, you should not be able to modify read only, all right, that's interesting. So it doesn't work that way. What if I want to make all of them as read only? As read only, it say, hey, no, I expect to be that as read only. Okay, no, this is as const, right? As const. Oh, but I think is should not be able to modify read only. But if I put it this way, it doesn't allow me to do so. As const, it doesn't allow me to do so. So, but in any case, the read only. So whether if I'm adding all of this as read only, all right, or I can use on the read only. Does it work? The read only array. Or you can say the read only. No. Read only search parent. Or you can say something like this, read only. Are you not going to complain with that? Yeah, you're complaining. That's fine. It says this type read only search patterns. Okay. So what about in the utilities, right? On the utility types, read only. Exactly. I was looking, it's like at the toolbox, right? So read only, right? At the read only type, right? And now this is supposed to work. You need to say no, this is not as it is. Remove type parameter. What? No, but I want to use is the read only type, right? How can I use that to const to read only to do? Oh, is when I'm going to use that. Okay. So when I'm going to use that, I say read only as it is. Okay. And it throws some error to say, hey, well, you should be able to update it, to mutate the value here. Makes a lot of sense. And the other, okay.
Ready? Sometimes the answer is just right there, read-only. And read-only, it applies to objects, and it basically says, okay, for all the objects in here, this is now going to be read-only. And so you're going to get errors on every single one of these because it's a read-only property. Still doesn't change anything about the properties, they're still totally optional, still got all of the members of the literals all tied in, but it just turns them read-only. This only happens one level deep, like most of the TypeScript type helpers, it only operates on the first level. So it won't make it kind of like, how do you say, like recursively read-only or anything like that, but it just operates like an object.freeze, freezing the object, making sure that on the type level you can't change anything about it. And again, nothing happens at runtime, just extra type information. Really nice.
But again, it goes into the mutability aspect here.
Okay, we have a very similar setup to what we had before, which is we have a modify button function which takes in some attributes. These attributes are typed as button attributes, so type button, submit, or reset. Then we have a const down here of button attributes, and it says type button in there, but when we pass that into our function, it's not working because argument of type string is not assignable to parameter of type button attributes. Very annoying, and the reason this is happening is because button attributes.type is mutable. Now, we found a solution to this before, which was all about kind of adding an extra type annotation to button attributes.
Exactly.
That worked fine, but there's a kind of more interesting way that leads into a really, really cool piece of TS syntax. We would be able to basically get the annotation right, or get the inference right, if we could just say to TypeScript, treat this entire button attributes const here as if none of the properties inside can be changed. So make the whole thing kind of like read-only deeply. Your job is to try to find that annotation and see if you can apply it to these button attributes. So now you basically, these are the only lines of code you're allowed to work on, the const button attributes equals type button, and you're not allowed to use the button attributes type in order to do it. There is such a cool way to do it. Good luck.
And the object types, so come with me, right here I am. The idea here is that how can I now, and all of this is just to tell the TypeScript how I want you to infer some piece of information, whether it's wide information, so like primitive, or literal values. And when you're working with objects, you can now, for example, tell TypeScript to inferring those values, right? I think you got this or not, but you can tell TypeScript to infer those values by saying something like this. So follow me here on this exercise, right? Say the 101 of the problem, and because again it's trying to inference the type of this. When you're using now const, it's gonna get the literal type as long as this is a primitive, but for objects it doesn't, right? Because you can modify is the so you can mutate is the value of this identifier at the bottom attributes, right? So because of this behavior in JavaScript, so we have now this as the so we can use so we can tell the compiler treat all of these properties here as read-only, aka as they are now to get the literal types from, so the literal values out of this. So we're using now const here, right? And when you now run this exercise, right, it actually works, right? So that's interesting because now you are telling the compiler to say, hey, if you have now in this object's values, so at this level of these objects, get me is all, so treating all of this as read-only values, aka inferring the literal types from this, like this. So it's like you're putting out this read-only type button, and this actually work as expected. But again, the whole notion is the mutability aspect when you now use your primitive and an identifier to as a bucket to fill in with any primitive that you want, and how they behave here, whether it's with let, whether it's with var or const, and it makes a ton of sense. Okay, got it. Let's take a look now at what Matt has to say here.
Okay, button attributes then. How do we make this read-only, like deeply? Well, we can add as const to button attributes. Before, button attributes was being inferred as type string, so type was mutable, but then if we add as const, it now adds a read-only modifier to that type. Not only that, but it's now being inferred as button instead of just type there. Or just string, rather. Beautiful stuff, and this is such a nice pattern because we're going to see the applications of this pattern in a bunch of different ways. Like declaring configuration objects in TypeScript is really common, you know, like different environments for different keys and things. And so being able to say, okay, this entire object is consted is just beautiful. And of course, this has no runtime cost. This just disappears at runtime. And so, of course, like TypeScript very rarely, and I think pretty much never, touches your runtime code, apart from if you're using a couple of features which we'll talk about way further down the line. But just by adding this type annotation, you get read-only on it. So if I say button attributes.type equals whatever, it's not going to let me do that, and it infers the literal as const. Very useful, as we'll see.
Again, all of this is just the mutation aspect, which is a behavior of how you now would it's a JavaScript behavior for you to identify how this bucket that you want to fill in with something, whether it's primitive values or objects, right? How they're gonna behave there, right? Are they gonna behave like a let, where you cannot redefine this name again, but you can mutate the content of this bucket, all right? Or you like to use const, so I don't want you to rename or even modify the content of this bucket. Or the var, which has a very interesting behavior, which is hosting, as well as the function, which is another keyword that actually host as well.
We've got a similar setup to what we had in our previous exercise. We're still on with the button type, and we have some modified buttons. Now, modified buttons, it's got a slightly modified version of button attributes. So button attributes, this is apparently the way I'm saying it now, takes in two buttons. It takes in cancel and confirm, both of which are objects with type button type. And button type is still button or submit or reset. Now, button attributes down here, we're doing an object.freeze on them. An object.freeze basically just freezes the object essentially and says, okay, you can't modify properties on this. So your job is to work out why this is erroring, because as we've seen with as const, surely this would just work, right? So your job is to diagnose the error, try to find an alternative way of doing this, and the code you can change is this button attributes set here. Good luck.
So let me go now to the exercise here and say, hey, well, let's take a look. That is 101, no, 102 here. And if I try to go with the same trick, right, that saying is like, hey, this is as const, it won't work. You may wonder, no, I mean is you can say something like this as const, right? It won't work because now it's a const assertion can only apply to reference to enum members or string, number, boolean, array, or object literals, right? So in this case, is say, hey, you're trying to apply this, all right? But to prevent the modification of existing property attributes and values and prevent the addition of new properties. So this actually works one level, no nested levels, you know, no deep nested levels. So cancel type as it is, it doesn't work as expected, right? Because now this is the shape of this, right? The shape of this is say, hey, this is now a read only of the cancel type, and it confirms. So if I want to now apply the read only attribute to all of them, including the nested objects here, right? All right. Whether if I now have to explicitly say something like this and something like this, right? And again, this won't infer this nested types. This won't infer is the nested types here. Okay, yeah, it won't inherit the nested types here, like as you can see here. So in that case, so whether if we get that value and we pull out of that, all right, and if we're trying to say as const, I think this won't work. No, you can say is the read only, right? Read only the read only attributes like this, and it say, hey, these attributes here is declared, but its value is never read. So if I go to here and say, hey, the argument read only cancel type that string that is not assignable to a parameter of read only the bottom attributes. So the type of cancel types are incompatible between this type. The type string is not assignable to a type bottom. So so somehow the first here or this read only is just applying to one level, as you can see, right? So the question will be is like how you can apply that to nested thing here, you know? If we go back here to the code here and the solution, all right?
Okay. So the difference between object.freeze and asConst is kind of what we're looking at here. If we hover over button attributes, you'll see that there's a read-only modifier being applied to the object that's being inferred here. But you'll see that cancel type is still inferred as string here, and not the literal of button. Oh dear. So object.freeze, as it turns out, it only works on the top level. So if we were to add like another type up here, let's say type blah, 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 then when we hover over button attributes, you can see that this is type blah, 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 blah. And then if we try to modify this, you see button attributes dot type is this, we would get an error here. But as we can see, if we go one level down, if we go confirm.type, then there's no more error. So the difference between object.freeze and asConst is that object.freeze, first of all, runs at runtime, so it's more costly, and it doesn't go all the way down the object. It's not recursive. It only works on the very top level. So the way to fix this is instead of using object.freeze is to say asConst, and of course.
But again, it's the behavior of this particular tool here. And if you want, okay, it's because that works at or do is, okay, it works at one level, at the top level.
Remove the extra type we added in there.
So so you can is remove, and this is an behavior at runtime. Okay, this is behaviors at runtime, and this is behavior at dev time here. So now button attribute is actually recursively going down to all of this. Okay. Holy moly.
So there we go. Button attributes now, if we hover over it, it's read-only all the way down, the whole tamale. So we've got read-only cancel, read-only type is button, and it's inferring those literals too. So in general, object.freeze I think is not a great idea to use unless you really want to make sure it's frozen at runtime, as const has no runtime cost and does it recursively. Super nice.
Okay, so that'll be all for this video. Take care. Bye-bye.